Welcome to This Explainer. Today, we're jumping straight into the terrifying speed, mechanics, and raw kinetic power of a truly catastrophic event, the August 26, 2026 Himalayan flood. We're going to be analyzing the data and tracking operational logs from the simulated disaster zone, which is part of the environmental geophysics and endless river framework, to get a really sobering look into the sheer destructive potential of high-altitude hydrological events.
To truly understand the mechanics of what happened here, we have to start by asking a pretty fundamental question. What actually happens when a massive, ancient geological force suddenly breaks free? What happens when millions of tons of static ice perched thousands of meters up in the sky just instantly converts into kinetic energy and follows gravity straight down into a populated valley?
Okay, so let's define exactly what we're dealing with. We're tracking a GLOF, a glacial lake outburst flood. And listen, this isn't your standard seasonal high water or some monsoon swell. This is a catastrophic flash flood caused by the sudden, violent release of water and debris from a glacier. So instead of flowing like a normal river, it basically acts as a high-velocity hydraulic battering ram, channeling this hyper-concentrated slurry wave straight through a steep mountain network.
We're going to track this massive force along a 44-mile descent across 4 specific waypoints: the genesis point, the border choke point, the engineering corridor, and finally, the valley dispersal.
This timeline maps out our really unrelenting spatial journey. It usually takes a normal river days to flow. This pulse-type disaster accomplished in just 2.5 to 3 hours. It's literally a ticking clock. It starts at minute 0 with the initial trigger, hits the border checkpoints by minute 15, devastates massive hydro infrastructure by minute 60, and finally disperses out of the gorge by minute 170.
Section 1. The Genesis Point, sitting at an elevation of over 5,200 meters.
Just think about the sheer vertical scale of this origin point for a second. It's high up in the isolated Tibetan mountains, right near the Nepal-Tibet border. At 5,200 meters, a massive section of a hanging glacier sheared completely off the mountain crest. And it didn't just slide down, it detached entirely, kicking off a catastrophic chain reaction in the blink of an eye.
The seismic and avalanche trigger was logged precisely at 8:37 a.m. local time. That plunging mass of ice and rock crashed over 1,000 meters straight down into the upper Lende River Trench. And this violent impact created a temporary, just incredibly unstable debris ice dam. It pulled massive amounts of water behind it until it violently breached, and that unleashed the surge down the Bote-Koshi River system. Because of this single, massive release, downstream rivers like the Trishuli would reportedly spike by as much as 9 meters in just 30 minutes.
Moving on to Section 2, the border choke point, from Rasuagadi to Tumare.
So just 10 to 15 minutes later, velocity becomes the absolute crucial factor. We're looking at speeds up to 34 miles per hour. Because the terrain here is this heavily restricted, narrow, V-shaped gorge, all that massive volume of water, ice, and displaced rock just couldn't spread out. It was squeezed into a hyper-concentrated slurry moving between 22 and 34 miles per hour. It acted like a giant natural funnel aiming straight for downstream settlements, with absolutely no buffer zone.
Now, at 34 miles per hour, millions of tons of rushing water cannot simply make a sharp turn. This triggers something called super-elevation mechanics. Basically, centripetal force causes the surging water to climb right up and over the outside banks of a steep canyon bend. This 100-foot-tall surge literally climbed the canyon walls, violently scouring the flat alluvial benches and leaving behind this raw, white scar on the landscape. All the soil and vegetation were stripped entirely clean right down to the bedrock.
And this immense vertical pressure wiped out critical infrastructure instantly. It engulfed the subsistence hoop greenhouses and terraced farms of Sikyong village. It completely obliterated the historic Rasuagadi Friendship Bridge, severing international transit. Just like that. It swallowed the Timur health post and scoured away major trans-border banking and customs offices, like the Nepal Investment Bank and Sanama Bank. The people working and living here literally had mere seconds to react.
Section 3, the engineering corridor, heading from Saifarbusi to Upper Trishuli 3A.
Remember our ticking clock, right? We are now roughly 30 to 60 minutes after the initial trigger. As the surge barreled southward, the sediment-heavy flood wave inundated major modern infrastructure.
It heavily damaged the 60-megawatt Upper Trishuli 3A powerhouse and submerged multiple multi-megawatt hydropower project sites. The chocolate-brown water level rose vertically by dozens of feet, overwhelming the valley benches and tragically trapping workers inside subterranean hydro tunnels, heavy machinery yards, and construction camps.
Think about this really profound geological transition. We have these massive concrete-lined portals bored into solid bedrock. In their current state, they were active, highly vital engineering projects. But choked with gravel and silt from the flood, they instantly became buried geological remnants. Long-term geology reclaims human engineering so incredibly quickly here, leaving behind subterranean artifacts that future archaeologists might one day uncover and marvel at, wondering what these massive structures even were.
Finally, we hit Section 4, the Valley Dispersal, from Bichrawudi Bazaar to Devighat. 44 miles. That is the staggering distance this destructive, debris-laden wave actually traveled. From that 5,200-meter high-altitude detachment point up in Tibet all the way down the river corridor to the wider valley floor near Devighat, it acted as a focused, high-energy freight train the entire way, just completely rewriting the geography of the gorge.
The physics of this disaster radically shift across the geography. Up in the narrow, V-shaped canyons of the upper gorge, extreme confinement creates this high-velocity bulldozer effect, which leads to complete structural obliteration. But as it hits the terminal basin near Devighat, the steep confinement finally ends. The floodplains widen, the kinetic energy dissipates, and that concentrated obliteration transitions into widespread inundation and massive sediment spread. And while the acute wave itself passed quickly, severe high-water conditions and blocked drainage kept these terminal rivers at an impassable flood stage for well over 24 to 48 hours, which severely hampered early rescue chopper approaches.
The resulting human and infrastructural toll of this 44-mile descent was absolutely staggering. Over 350 confirmed fatalities combined across the borders. More than 1,300 people left missing, including local villagers, workers, Indian pilgrims, and foreign tourists. 1,200 people were officially displaced. On top of that, the sheer physical damage, dozens of bridges wiped out and nearly 40 kilometers of strategic roads destroyed, completely severed these remote valleys from the rest of the world. It made search, rescue, and recovery operations incredibly difficult.
As we wrap up this explainer, I want to leave you with a provocative thought. We've seen exactly how quickly and violently the landscape can reshape itself. So when ancient geological forces suddenly awaken and millions of tons of ice reclaim the geography in an instant, how can humanity possibly defend its fragile infrastructure in these steep, unforgiving energy corridors? It's really a question of engineering, survival, and a deep, necessary respect for the raw power of the mountains. Thank you so much for exploring this data with me today. Keep asking questions and keep learning.